Hello, in today's lesson we're going to be doing an introduction to standard normal curves and normal distribution. Let's now move into the normal distribution. First, let's review what discrete and continuous data are. Discrete data can be counted. It can be found exactly. For example, if I'm looking for the number of students who have black hair or blonde hair or brown hair, I can know exactly how many they are. They are separate and countable. Continuous data, for example, the weights of babies or the heights of students in the class, is rounded. 3.7 kilograms means it's somewhere between 3.75 kilograms and 3.65 kilograms. You often see this. Go 1 decimal to the right and add 5, go 1 decimal to the right and minus 5. And you're somewhere in there. Our continuous data is rounded. What is the normal distribution? The normal distribution is a model for real data. The predictions made by the normal distribution are approximate. It's only approximate. It's not exact, and it works best in situations in which the data clusters around a particular mean as a result of random factors. Variation about the mean is measured in standard deviation, which we know is the square root of variance. So we're going to measure spread by SD, and the mean is going to be at the center of our graph of a normal distribution. Here is our standard normal curve. There's a few factors that I want to point out to you that are very important. The mean of a standard normal curve is 0. Here is my mean in the middle, and it's got the highest value at around 0.4, and that is my mean. The standard deviation is 1. Here is 1 standard deviation, 2, 3 standard deviations to the right, and 1, 2, 3 to the left. We're measuring something called z. This is the function value of z is represented by 1 over the square root of 2 pi times e to the negative z squared divided by 2. You don't really need to memorize this, but that is what the function, that is the function value to get this curve. Z is continuous. I don't have to pick up my pencil or my pen as I draw this curve. What's important here is that the area under the curve, not the height of the curve, represents the proportions of the variable between two given values. If I want to find the proportion between -1 and 3 SDs, I want to find the area. I'm not concerned so much with the height of the curve. Again, the most important thing is that we have a mean of 0 and a standard deviation of 1 in the standard normal curve. Let's talk about using the standard normal table, or I'm sure many of you are going to use your calculators to do this. The table or your calculator tells us the proportion of values of the standard normal variable that are less than the given values. For example, a value of 2 corresponds to 0.9772. Well, what does that mean? You can interpret it 3 ways. It means the proportion of values less than 2 is 0.9772. The percent of values less than 2 is 97.72%, or the probability of a randomly chosen value, if our values are normally distributed, less than 2 is 0.9772. Here is our value of 2, and here we're looking at a representation of 0.9772, or about 97% of our data is to the left, or less than our value of 2. If the random variable x is normally distributed, with mean it's a U-looking shape, and variance, remember it's not standard deviation, but variance, sigma squared, we write our capital X is normally distributed. This is going to be our mean here, and this is going to be our variance. So we talk in terms of mean and variance. If I have a standard normal curve here, let's talk about some of the properties of the standard normal curve. It is symmetrical about the line x equals this u, which is our mean. That's also our mode. Right here, our highest value will be our mode. It's also our mean. This side is the same as this side. I could have put a mirror here because we have symmetry. The normal curve approaches the horizontal axis as x approaches plus or minus infinity. As my x gets very, very large, my curve is going down to my horizontal axis, my x-axis. As my x gets extremely small, negative infinity, my curve is going down again to the x-axis. The total area under the curve is equal to 1. If that brings back to mind integration, well, here is our integration from negative infinity to infinity. That's our lower boundary and our upper boundary of the curve with respect to x. The whole area under the curve is equal to 1. And 95% of the observations occur if our value here is our mean, the u value. We're going to go u minus 2 standard deviations to u plus 2 standard deviations. So here is 1, 2 SDs and 1, 2 SDs. Well, if I think about the area enclosed by those two vertical lines here, I'm going to have 95% of my data is going to be between negative 2 SDs and positive 2 SDs. Let's talk about the standard normal distribution. Remember, a standard normal distribution has a mean of 0 and a variance of 1. It's important to remember that we can convert any normal distribution with a mean of u and a variance of sigma squared into a standard normal distribution. In other words, if I'm asking students at our school what is their shoe size, and I get from the boys that the mean shoe size is 10, look, that is not a mean of 0, and my variance may be 2 shoe sizes. That's not a variance of 1. To make it a standard normal distribution, I have to convert somehow this 10 into 0, and my variance from whatever it is to 1. Well, the square root of 1 is 1, so this would also be an SD of 1. So don't get fooled there. For a standard normal distribution, we can have any random variable x normally distributed with a mean of u and a variance of sigma squared. And we're going to convert that into the standard normal distribution, normally distributed, our z value, with a mean of 0 and a variance of 1, which also means our standard deviation, square root of 1, is 1. Here is the Harry Potter key. How are we going to do that? Well, our z value will be the x value we get minus the mean. So any x value minus the mean divided by, here we're given variance, we're going to convert that into standard deviation by taking the square root. You have to know this. If you don't know this, I can't help you any further. The z value is any value x minus the mean divided by the standard deviation.